So next I want to talk about the basics of API design. We know a few API paradigms, which basically allow us to control the interface of our API, the surface area, or you could also call it the API contract, which basically describes how we're going to use a particular API. We have some service. For example, this could be the Twitter API or the Reddit API or the YouTube API, anything. There's some functionality of an application. Let's assume this is Twitter. We want to do certain things with this. We want to maybe create a tweet or delete a tweet or edit a tweet. Well, you can't actually edit a tweet on Twitter, at least not until recently. So we're just going to assume that we can't do that. Or you want to see a list of tweets like for your home feed, or you want to like a tweet or retweet something, right? You can do all these things on Twitter. Now, the API design portion is only about the actual surface area of the API, how we're going to interact with Twitter, what we are going to do, what actions are we going to take, creating, reading, updating. That's basically CRUD. Pretty much most actions are going to be within the scope of CRUD, creating, reading, updating, and deleting some resources or entities. Entities are things. Entities are nouns. In this case, a tweet is an entity. It's a thing that we're going to be interacting with. It's a resource. And the verb create is mainly going to be handled. I'm going to be focusing on REST. So it's mainly going to be handled with the actual verbs like get, post, put, delete, stuff like that. But if you were doing this with an RPC framework like gRPC, the verb itself would actually be included in the endpoint. But again, the important thing about API design is we do not care at all about the implementation details of the API. We only care about the surface area, what we are actually interacting with as users. API design is pretty similar to just coding in general, right? Like creating functions, and each of those functions, has some input output. We don't care about the implementation of that function, but we care about what are the parameters or arguments that go into a function and what do we get back. After we create a tweet, we expect to, get a tweet in response to that, or maybe some error code telling us why it didn't work. But the reason API design is a really important topic in the real world is because with publicly facing APIs, we can't change stuff. Like, let's say we have a method or an endpoint for creating a tweet. Let's say it looks something like this. If we want to create a tweet, we have to give the user ID of the person creating the tweet and the actual text content of that tweet itself. So that's like our endpoint for creating a tweet. Now, if we implemented this with a REST API, which is how Twitter and actually the vast majority of public APIs are implemented with REST, this is an example of what it could look like. It would be a post request because we're creating a resource on the server, passing in a few parameters here, but those aren't going to be included in the endpoint definition. This endpoint could accept, a body, and that body itself could have some key value pairs. Let's assume it's JSON because that's the most popular. It could have a few key value pairs, the user ID and then the ID of that user, the content, which would map to, the actual string text of that tweet that we're creating. So it really is just like, object-oriented programming or just creating an interface or an object or a class. It's not super complex, but we have to be really, really careful with this because this is a public API. Let's say these two parameters are required for our endpoint, and we want to make some changes to this, right? We want to add some more parameters that you can add to a tweet. If we were just starting out with Twitter and we had this as our public API, and all of a sudden we wanted to add some crazy feature like being able to reply to tweets. Like, let's say this is a tweet and this is a separate tweet. These can exist individually, but maybe this tweet is actually a reply to this other tweet over here. Well, how would we modify our create tweet endpoint? Well, we would have to pass in, let's say, another parameter for the parent tweet possibly, right? And that would be, let's say, parent tweet ID, right? The ID of the parent tweet that this child is a reply to. Well, this is actually okay. This is acceptable because we will make the parent ID optional. It is not required. So what that means, if now users want to create a tweet that's a reply, we can use this parameter to the create tweet endpoint. This will be passed in the body. It works perfectly fine. But also at the same time, all the people that are using the original create tweet endpoint, the one that didn't even have parent ID available, that are just passing in two parameters, this will still work. The whole point of adding an optional parameter is that it is backwards compatible. The people using the older version will not break. But what if we added parent ID and when we made this required, that means all the people using the original endpoint aren't passing this in currently. I mean, they could update their code maybe pretty easily to do this, but if we push these changes to our API, it will break literally 100% of the existing users until they update their requests to pass in another parameter. That's why we have to be very, very careful with API design. It's an important topic. Being backwards compatible is really, really useful. But of course, there are going to be some changes sometimes where we have to introduce new required parameters, or we have to just change and redesign the entire API. In that case, we would not have a backwards compatible API. And that's when versioning comes in. Typically, most APIs will have some type of version associated with it. You know, this is an example where the first thing in our URL path here is the version of the Twitter API. Twitter has, I think, a couple APIs. They have version 1, and this is kind of a common way of doing it. I think Twitter actually doesn't even have the V. They just have the version itself. Stripe, I think, does have a V, but you know, that's a small detail. But the point is that the version of the API is important, because now if we introduce a new version of this API, we will not break the original API. We'll have two versions of the API coexisting at the same time. Now, after a tweet is actually created, that tweet will have some information that we didn't necessarily pass in. A tweet is created server side, and we assume it'll be persisted to some database, but like I said, we don't have to worry about the implementation details. We're just talking about the interface, the API contract. You pass in some parameters that are optional or required, you get back a tweet. Now, the tweet itself could look something like this. This is obviously really simplified. It could have a lot more, but every tweet is going to have some owner or user associated with it, like the creator, I guess would have been a better word for user ID here. But you know, there's going to be some unique user who created the tweet. The tweet could also have an ID itself to uniquely identify it, because you know, a user is not enough to uniquely identify every tweet. But of course, this tweet ID, for it to be universally unique, it would have to be created server side. But this is an implementation detail that we do not have to worry about, because when we create the tweet, we do not have to pass in the tweet ID since it is created server side. That's all you really need to know. It's not going to be sent by the client who's actually creating the tweet. But the user ID, though, does have to be sent because only users can create tweets. The content will also be provided by the client, like what's actually included in the tweet, but the timestamp that it was created at, technically it could be created by the client if we really wanted to. And then on the server, we could validate that this time is reasonable, like it happened, you know, at roughly the time that the request was reached by the server. But probably not a good idea to have this, because users should not be the one taking the timestamp at the time that the tweet was created at, because it's created on the server side. The server should be the one responsible for this created at time, so we do not pass that in to our endpoint. And the number of likes, of course, is going to be 0 initially, but we also don't pass that in when we're creating a tweet. That will be handled server side. But you know, tweets can be liked and unliked, so that is some additional functionality we'd have to include into our API. Now, if we wanted to actually get and retrieve or read an individual tweet, obviously when we create a tweet, we get that as a response, but we should also be able to read tweets after they've been created. We should be able to read tweets that we ourselves have not created. So we'd have a very, very similar looking endpoint here. The URL is almost the exact same, but we have one additional parameter. This is a URL parameter. That doesn't mean that the URL is going to be v1/tweet/ID. This is a parameter. There's going to be some value that we put here, which is going to be a tweet ID associated with an individual tweet. A get endpoint would be to just read that tweet and all the information associated with it. We could also have had a delete endpoint, which would be responsible for deleting that tweet, but only if we are the actual creators of that tweet. So we would probably have to pass our user ID, and probably some more additional authentication and authorization would go on in the back end, but that's something that's out of the scope of API design typically. Now, what if instead of getting an individual tweet, we actually wanted to list all the tweets for a particular user, just a single user? We want to list all of their tweets. Well, a single user could have a lot of tweets. I mean, some people on Twitter just go crazy. They have thousands and hundreds of thousands of tweets. Pretty insane if you ask me, but it is something something we still have to handle. So of course, we don't necessarily want to return every single tweet in a single request. That might crash the user's browser, and it's pretty unlikely that they would want to see thousands and thousands of tweets. So we do what we kind of talked about, which is pagination. It's very, very important in API design to have pagination when you're listing a large amount of data. And it's basically handled with two parameters that we kind of talked about. One is limit. This is sort of the max size, the max number of results you want to be returned by an endpoint call. So for example, we could pass in list all of the tweets for a particular user, but limit it to just 10 tweets. Now, what if that user has 100 tweets? Well, we're only going to see the first 10. Maybe we're sorting it based on chronological order, right? Like based on the created at timestamp, but possibly the user doesn't even have 10 tweets. What if they only have one tweet? They just created their first tweet and we call our endpoint with limit 10. We're only going to see a single tweet. So this is the maximum that we could retrieve. But now suppose we want to see 10 more tweets. We need a second parameter, which I call offset because it's pretty simple. It basically tells us what's our starting point. You know, we could be starting at 0. That would be the beginning, the first 10. If we're starting at 10, that means we want the next 10 after the first 10, or we could be starting at some arbitrary position like 2500. Now we would definitely be listing a bunch of values using a get endpoint, but the thing about get is that there's no body for a get. We can't just pass in a bunch of stuff in the body of the get request. We have to take these and put them in the URL itself, either as URL parameters or as query parameters. But there's actually one problem. We can't reuse this endpoint definition because this is already reserved for getting an individual tweet. Given this path and some tweet ID, this should return a single tweet. Or maybe here we could actually have had, multiple tweet IDs, but the point is that this is going to return a tweet. This ID is based on a tweet ID or multiple tweet IDs, but if we want all tweets for a user ID, we should probably create a different endpoint. We're going to have the get as the HTTP method, but we need a different path. So let's try to create one. So this is what an endpoint for actually listing tweets for a particular user could look like. So we have our base path here, version 1.0, and then we have our user's resource. So we're starting at the user level, and then we're getting an ID. Usually we just have ID for short, at least I prefer to, but we could have also written here user ID to be a bit more specific, but typically ID is followed by the resource that it's applied to. So this ID applies to the user. And then after that, for a user, we have resources, aka tweets. And from the tweets, we just want to list them. So this is, what we're passing in, just tweets, or we could have just have tweet here as well. But important thing is that this is so long, it takes 2 lines to fit. This is still a part of the original endpoint, and these are the query parameters. By the way, I forgot that this is a get endpoint, but we have a couple query parameters, and these could be optional or they could be required. It's probably better to have this be optional because the default value, if we don't specify offset, the default value will probably be assumed to just be 0. We're starting at the beginning. If we don't have limit set, that doesn't mean that this should be limitless. That doesn't mean we need 100,000 tweets from a single endpoint call. This will be some default value, something reasonable like 50 or 20, something like that. So if we don't specify anything, it still works, but we can add additional query parameters that are optional so users have more control. Also, before we take a look at the Twitter API docs and a couple other docs to see what real APIs actually look like, I want to discuss a couple things about REST APIs in general. First of all, we've been kind of writing our endpoints like this in coding interviews since, it's more open-ended. Like we could have been using gRPC. It might be better if your interviewer just allows you to kind of interface a endpoint just as a function, like, the way we did with create tweets, and then that could have some parameters like user ID and some other stuff. And for actually defining entities like this, maybe just something like this works. With API design, that's really the big thing. Like, what are the entities that we're actually talking about? We have tweets, we have users. Well, that's actually pretty much it, but we have a lot of relationships between these things. Like users can have tweets, users can like tweets, users can follow each other. We could have gone, pretty in depth into the API design of Twitter, and we definitely would have only scratched the surface. But to kind of simplify this, usually instead of writing out the entire REST request endpoint, probably better to just kind of write it out as a function that takes in some parameters like a user ID, stuff like that. And then it returns an entity like a tweet. So we get the kind of input output and we don't have to worry about the actual implementation details. And also, you probably don't need me to tell you this, but when we make GET requests, we probably shouldn't actually create resources in our API. Getting is only for reading. We don't want to create resources with a GET request, pretty much as the name implies, but also because GET requests are supposed to be idempotent and they're assumed to be idempotent. That means if we pass in the exact same input parameters to an API call, we will get the exact same result after the first call. That basically means that, taking our very simple example where we're reading an individual tweet, like we pass in the tweet ID and we want to see all the contents of that tweet. If we call that endpoint once, we'll get the tweet. If we call it more times after the first time, it should not give us anything different. The tweet should not change as a result of GET requests. They should be idempotent. The reason that's important is for caching, because by default, GET requests are cached. So if we were misusing the GET request, which we technically could, we could make a GET request and the code on the server side could actually be creating stuff. Given a GET request, we might end up updating some content of the tweet. We could technically do that. There's nothing stopping us from doing that, but it's very, very bad practice. You'll probably never do it. And this is a pretty obvious mistake to avoid, I think, but still definitely worth mentioning because I don't see a lot of people talking about this. Okay, now let's take a quick look at how the Twitter API is actually designed. So these are the Twitter API docs. You can see here I'm looking at Twitter API version 2. There are other versions, as you may have guessed. And there's a lot of stuff here. Like, you could read this for a long time. There's a lot of details. We'll just be looking at a couple functionalities. You can see here under Manage Tweets, we have a couple endpoints for updating a tweet here. This 2 is just the version. This means we're using Twitter API version 2. And then we have a tweets path. So this would be added to like the base Twitter API, which I think is just API.Twitter. And you can see we don't need to pass in the tweet ID when we're creating one because that will be handled server side. But if we're deleting a tweet, we definitely need to pass in the ID of the tweet that already exists. Taking a look at how to post a tweet, you can see here we have the full endpoint URL. We have additional information about how this endpoint is rate limited. Like, we wouldn't want a public user to be able to make 1 billion requests to this in a second. That could crash the Twitter API. So we have some limit applied to it. In this case, it's 200 requests per 15-minute window. And we have some additional information about the API. Generally, if you're coding a public API, it's very, very, important to have good documentation. In many cases, if you add good comments to your code itself, you can generate good public-facing docs that are similar to this for every parameter. In this case, you can see since this is a post request to create a tweet, we will use the body of the request and it is formatted in JSON. That's the most common because it's very simple and readable. And these are kind of all the options that we could pass into the body. Most of these are optional. Pretty much all of them are, I think, which is pretty good for backwards compatibility. Now, taking a look at the timelines that we can actually create, there are a few. The simplest one, I think, in my opinion, is the actual user timeline. This is for a particular user. We want to see all the tweets that they have created. And you can see it's pretty much exactly like we talked about, where we start with the user's resource. And then for that user ID, we get all of their tweets. Taking a deeper look at this endpoint, you can see, of course, it's a GET endpoint. So that means if there are parameters that we want to pass into this endpoint, we can't do that in the request body. We have to do it in the URL. So scrolling down, you can see that we have that single path parameter. This is the ID, but it's a user ID. And the other parameters are query parameters like we talked about. And we sort of talked about limiting the number of tweets that we see. We can see that there's a similar query parameter for that called max results. You can kind of read the description here. It looks like by default, it will display 10 tweets at the maximum if we don't specify any max results, because this is optional. We don't have to specify it. And we talked about having an offset for keeping track of where we are. Like, we've seen 10 tweets so far. Now we need 10 more, something like that. Instead of using offset, offset. In the real world, it's more common to have a pagination token. This token would be returned by the first request, and it would basically keep track of how many tweets we've already seen. So we would take this pagination token and then pass it into the next request, and then we would get another new token in response. We just keep using the most recent token to get more and more tweets. So we definitely covered a lot so far. I definitely want to encourage you to take a look at some of your favorite websites and take a look at their public APIs if they have any. Most social media sites have some. I think Twitter's is relatively simple, so I wanted to start with this API, but there's actually other APIs. Like this here is the Stripe API. It's very, very good documentation wise. I think these docs are easier to navigate and read because they're just more put together. But since Stripe is related to payments, it's not something that's easily as understandable as tweets, something that most people are familiar with, like a social media site. You have a lot of things like payment intents and things that you might not immediately understand unless you've actually used Stripe before. But there are some pretty cool things that you can learn. I definitely recommend, reading through some public API docs. Like here, you can see something cool that Stripe did is they have these really large objects. This is a payment intent object. There's a lot of information, and a payment intent is associated with a customer. So what Stripe does, it makes this customer field expandable. What that means is by default, this payment object will return some customer ID, but that customer ID could be expandable. That means when we make that request, we can basically choose to expand the customer object. That means instead of getting the customer ID, we would get the entire customer object. But if we don't need that, we shouldn't expand this. So this kind of gives us similar control that GraphQL does. We can choose multiple resources that we want, or we can choose to not include resources that we don't need. So while we covered a lot, we really only scratched the surface with API design, but I think this definitely gives you a really good foundation of what you should focus on. You want things to be backwards compatible, you want endpoints to be clearly defined, and you don't want endpoints to conflict with each other. You want to provide pagination. These are really the core basics that you should have a good understanding of.